Okay, good afternoon, guys. My name is Said Motondo. Today, I want to take you through the starting routes on Cisco iOS routers and labs. First, starting routing. The static or manual method to add entries to the routing table is known as the static or manual routing. Routes that are manually added by an administrator to the routing table are known as static routes. In simple term, the static routing is the method, and the static routes are the routes added manually. So, in other words, a static route is a route that you manually add to the router's routing table. Starting routes are ideal for small organizations with network of around 10 to 15 routers, because as you know, we are doing manually for each and every router, and we do the reverse of the configuration. So imagine you have an organization, or you are in an organization with 100 or 50 routers. It will be impractical to do the configuration each and every one. So starting routing as an AD or administrative distance value of 1 means the smaller the AD value, the more they're reliable. For example, for the directly connected routes or protocol, we have an AD of 0. It means this is a very trustworthy connection. And we have like a static route, we have an AD of 1. So it goes on to other protocols like OSPF and extra. Starting routing support a classical networks, like classical networks. As we know, we have class A, /8, class B, /16, and /24 for class C. So in order to configure starting routing in a Cisco iOS routers, this is the command syntax to use. So you have to route, then we define the destination network or host with the subnet mask, and we identify the next hop IP address or the next hop interface. This is a simple configuration I think we'll do. First, we should mark the IP route keyword, then destination network, destination mask, and the next hop. So we'll do the lab on this. We'll see how it's being done. Sorry. Minutes. Okay, this is lab 1. For lab 1, let me erase this. For lab 1, we have this topology diagram, and we have host 1 and host 2. Our objective is to make sure that host 1 can ping, host 1 can ping host 2, and vice versa. So with this, we have two routers, set 1 and router set 2. We have to configure the static as our syntax. We configure on the global configuration mode, configure IP route, destination network, this one for router 1, and this is the mask, network mask, and we should identify our next hop. And our next hop for this network, when we want to access this network, our next hop is this router .2. And for router 2, to access this network, our next hop is 1. So we have to configure IP route for this so that we can ping between these hosts. We'll do it later. Let me explain another topology, which actually is similar, but we have just minor change. Okay, we have for the same static routing. For this one, we have 3 things. Our objective is to make sure that client 1 can ping client 2. And as you know, as you can see here, we are in different networks. And from router 1 and router 2, these are directly connected with a D of 0. So these can ping each other without any protocol configuration. But to access this LAN, we have to configure the routing. So for R1, IP route, our destination first, we should identify this because they are not directly connected. So our network is 20.20.20.0/24. It means 255.255.0. Our next hop to reach here is this. And IP route to this network, this one, our next hop is the same. So for router 2, IP route, we have 2 networks which are not directly connected. We have this one and this one. So 1 and 2, IP route 1 and 2.168.1.0. To reach here, we have to pass our next hop. We have to pass through this 10.10.10.1. And to reach here, 1 and 2.168.2.0, we have to pass through our next hop, 20.20.20.3. So this is the configuration for router 2. And the configuration for router 3, we have this network and this network, which are not directly connected. So to access this, we have to pass through 20.20.20.2, and to reach here, we have to pass 20.20.20.2. So let's do the configuration of these static routes before we move on to another lab or another concept. Let me clean our whiteboard. Okay, we are here. I have this lab. I've already set up this trap, and I have my console opened. Minutes. I've done it. I've just opened the console and also configured the interfaces IP because of the time. For example, here for site 1, first I have to see if there's any configuration. IP interface brief, show IP interface brief. Sorry, so show IP interface brief. Okay, I've configured the interfaces. I've added the IP addresses for interface 0/0 F0/0. This is our IP 1 and 2.168.1.1. and it's up. For interface G10, 192.168.10.1, and it's up. And for such 2, show IP interface brief. Okay. For F0/0, it's up 192.168.2.1. For interface G10, 192.168.10.2. And also we have our host 1. Let me check my IP address. Yes, we have IP address of 192.168.1.100, and this is our gateway. We have 192.168.2.100. Yeah, this is our gateway. So now what we do, we configure the static route. We enter into global configuration mode, and configure the route, IP route. Our destination network is 192.168.2.0, 255.255.255.0, and our next hop. Our next hop is 192.168.10.2. Okay, let me see. Show IP route static. I want to check my route. Yeah. So for S means static. 192.1 to reach 192.168.0, we must pass through or via 192.168.10.2. And as I've said earlier, that for static route we have a D of 1, and 0 is the metric. I think we'll discuss about metric in another video. So we should configure the reverse of it. Configure IP route on such 2. Our destination network is 192.168.1.0, 255.255.255.0. Our next hop is 192.168.10.1. Show IP route specifically static. Yes, now we can actually see our static route here. I can save my configuration. You can just type write or RW. Now, let me ping my next host. Ping 192.168.2.100. Yes, you can see that I can now access my host 2 because we have configured the routing, the static routes between the routers. I think we are good. Let me move on to the next lab. This is our next lab. Static route lab 2. Okay, this is our lab. Let's start all our devices. Okay, here now we have the same. As you can see, we have a PC1, PC2, and our network diagram. So we have now to configure IP route in R1, R2, and R3. Let's open the console for R1. Delete. C1. C2. Of course, minutes. I want to check my configuration. If there's any configuration, show IP int brief. Yeah, we have configured for interfaces address, and they are up for router 1. Let's check for router 2. Show IP int brief. Yes. Router 3. Show IP int brief. Yes. Okay. Let's show on our PC1. Okay, we have our IP address on PC2. Okay, let me try to ping, but I have not configured the route. Let me try to ping if I can access the client B. Ping 192.168.2.100. Let me check. Show IP route static. So, sorry, I was pinging on its own, on itself. Ping 192.168.2.100. As you can see, we cannot ping because we have not configured the routing, so they cannot communicate with each other. So now let's configure proute. Now for R1, we have to access 20.20 network and 192.168.2 network. So IP route 20.20.20.0 255.255.255.0. Our next hop is 10.10.10.2. IP route route 192.168.2.0 255.255.255.0 10.10.10.2 is our next hop. Let me try to check my route IP. Show IP route static. Yes. For this destination, we have to pass through this next hop, and for this, we have to pass through the same next hop. So we have to configure R2 IP route. Now we have destination 192.168.1.0 255.255.255.0. Our next hop is 10.10.10.1, and our next route is 192.168.2.0, 255.255.255.0. Our next hop is 20.20.20.3. Show IP route static. Yes. For this destination, you have to pass through 10.1, and for this network also, we have to pass through 20.3. Now, let's finalize with this configuration for R3. IP route. For R3, we have this network and this network. Sorry. We have this network and this network, which are not directly connected. IP route 10.10.10.0, 255.255.255.0, 20.20.20.2. IP route 192.168.1.0, 255.255.255.0, 20.20.20.2. Show IP route static. Okay, now to reach this network, we have to pass through .2. The same time to reach this network, have to pass through .2. So let's try to ping and check if now we can now access our next client. Time out. Let's wait. Okay, we have a timeout. We have to troubleshoot to see what is happening. Let's go back to R1, show IP interface brief. 192.168.1 .1.1 10.10.1.1. Okay. Show IP route static. Yes, it's okay. 10.10.2, 20.10.0, 192.168.2. Let me check. Let me try to ping 20.20.20.2. Yes, I can access .2. .3. Yes, I can access .3. Let me check. 192.168.2.3. Can access .3. So we have issue. Let me check our IP address. Okay, our gateway was 192.168.2.3.1, not .2.1. we have to change, sorry for this, IP 192.168.100/24. Our gateways were 92.168.2.3. Yeah. Yes. Let's try to ping again. Okay, we can now access. We can now ping host B. Let's try again, as you can see. So with this troubleshooting, I've discovered that I've used a different gateway for this host B, but it's now okay. It's now okay. Okay, this is the lab for the static root. Let us move to another concept of the same static. Now we have host. Now we have another concept of host static root. What is host static root? The host static root is configured to route packets to a specific host. The subnet mask will be all ones. It means for a specific host, the subnet mask is normally 255.255.255.255 for class C. The IP version 4 subnet mask for the host route will always be the /32, yes, and the IP version 6 subnet mask of a host route will always be /28. The host routes are the most specific routes possible, and therefore take precedence over all other routes based on the network mask. So for the first lab, we were dealing with the network route from one network to another. Then within the network, we have host. But now for the host static route, we have to specify the host, like the server. Like here now, for this host, to access this host, I want to specifically configure our routers for this server. Sorry, it's not /32. We have to configure our routes, specifically the host static route, specifically to direct our routes to the server, not to the network, or to this host only. Okay, for this, we have to configure like our branch here, IP route 192.168.1.100. We have to specify, and the subnet mask should be all 1 or /32. And to access this host, our next hop will be this one, 192.168.10.1. And we have to configure this we have to configure the reverse on HQ router, 192.168.1 to access .12.0 to access this network. We have to pass through 192.168.10.2. Let's do the lab and see how it's being done. This should be, sorry. Okay. I want to remove this one. Okay. Let's move on to the lab. This is our lab. Let me cancel this and open the host routing lab, host lab 1. This should not /32 is /24 because it's just our host here. Okay. Let's open the console of branch router. Console of this should be HQ. Let's stop first and rename. This should be HQ. Okay, let's start all our devices. Okay, let's connect. Let's have the console of HQ. The console of PC1, and we have a server here. I've already configured the server. What we'll do is just configure the routes and try to ping if we can access the host. Now, it's booting. Okay, we are on branch router configure T. Sorry, I have to check our interfaces. Show IP int brief. Yes, 192.168.12. Yes, .1, 192.168.10.2. Yes. Show IP interface brief. 192.168.1.1. Yes. 192.168.10.1. Yes. Okay. We have to configure now the route, IP route to the host, which host is 192.168.1.100, 255.255.255.255. We have to pass through 192.168.10.1. Okay. Show IP route static. Yes. To access this host, you have to pass through or via 192.168.10.1. Yes, this one. HQ IP route 192.168, this network now, .12.0.255.255.255.0. Now, to access this network, you have to pass through 192.168.10.2. Show IP route static. Yeah. Now, for this for HQ configuration, we have a destination network, but for the branch, our destination is destination host or IP. Let's try to ping the server, ping 192.168.1.100. As you can see, we can access the server because we have configured the route to the server for the specific. If you want to be specific to a particular host, you can just configure the route to the specific host. Save. Can also save here, right? You can save by do the copy, run, start, or you can just type write. Okay. Let's go to our next concept. Now we have the floating static route. Floating static routes are static routes that are used to provide a backup path to a primary static or dynamic route. The floating static route is only used when the primary route is not available. So for the static route, we use this for the backup in case the primary route fails. So to accomplish this, the floating static route is configured with a higher administrative distance than the primary route. The AD represents the trustworthiness of the route if the multiple paths to the destination exist. The router will choose the path with the lowest AD distance. I said earlier that we have different routing protocol with different ADs. Like for the directly connected, we have AD of 1. The static, we have an AD of 1. The direct connected, we have an AD of 0. And the static, we have an AD of 1. And so on. We have different routes and different ADs. So now, for example, here now, for router 1, for our host to access host in this side, and now we have backup. We have one route and a backup. But we want to configure so that we can use the primary, but in case the primary fails, the router can change the path automatically. This is the syntax. IP route, destination network or host, destination mask, and the next hop address or interface, but we have to include the distance. For the primary, we have for the primary, we have the destination IP, destination network, and our path. Our next hop is 10.10.2, but as you know, we have an administrative distance of 1, but you cannot. We can ignore it. We cannot write it here on the configuration. But for the secondary route to the same destination, we have to specify the administrative distance, because the lower AD, the more trustworthy, and the router will choose the route with the lower ID. Choose this as the primary, and then this will be the secondary route. let us configure this. Let us configure our lab so that we can understand it better. Sorry. Now, let's move to our lab, GNS3. We have for the floating lab. Let's wait for it to load. Okay, this is our lab. I've just added this. I want to trace route to check if we can, which path will be used. Let's run the console. Let's open the console of router 1. First, let's close this one because for the last lab. Let's run the console again for router 1. And let's run the console for router 2. For router 1. And let's run the console for host. I want to arrange them in order. Router 1, router 2. And then hosts. So, okay. Still booting, okay. Show IP int brief. Yes. The pieces are up and running with IP addresses. Show IP int brief. Yes, up and running. So let us configure the floating, the static floating. Configure to on the global mode IP route. Now our next hop or our next network, our destination network is 192.168.255.255.255.0. Our next hop for the primary route is 10.10.10.2. Again, the same destination, but our next hop here is 20.20.20.2, but we want to make it route. That's why we have an administrative distance of 10. Now let's configure for the router 2 IP route. Now sorry for router 1. For router 1, our destination network is .2, not .1. Let's move this and Let's move this. Let's set up IP route. Sorry. IP route 192.168.2.0 255.255.255.0 first route 10.10.10.2, and the secondary route will be 20.20.20.2 with AD of 10. Yes. Show IP route static. Yes. For the start, it has picked the trustworthy one among the two, and our trustworthy one was this one, because the secondary route it had an AD of 10, so it could not be picked here. For R2, IP route 192.168.1.0 255.255.255.0. Next up 10.10.10.1. Next up here is 20.20.20.1 and a D of 10. Okay, let's show IP route static. As you can see, it has only picked one route for 10.10.1. So let's try to ping. Let's try to ping 192.168.2.1. It's time. Okay, I think we have issue. Show IP int brief. Okay, this is a router, but I've just configured it to be my PC because I want to trace route. For the virtual PC, I cannot trace route. I have to configure this router as a PC, so I have to configure the route to access the network 192.168.2.0. So let me try to check something. Show IP route. Okay. I want to configure a route so that I can do the trace routes and pinging. IP route 0.0.0.0. I have to add my gateway 192.168.1.1. Show IP routes. Okay, let me try to ping 192.168.2.2. I think we have issue. Let me try to ping from my router. Ping 192.168.2.2. Unreachable. Let me check if I have the correct configuration on the interface. So IP int brief. Okay. I've not configured this interface E32. So config interface E3/0 IP address 192.168.2.1 .2.2 255.255.255.0. No shut. Okay. Let's try to ping again. Okay. Show IP int brief. I've not also configured the interface for config T. Sorry. Config T interface E3/0 IP address 192.168.1.1 255.255.255.0. No shut. Okay, I think we are good to go. Okay, we can now ping. So trace route. Wait. Okay. Trace route 192.168.2.2. And you can see now we have used the packets I've used through passed through 10.10.10. as a primary. Let me try to shut the interface for interface G1/0. Let me shut for the primary and interface G1/0. I want to check if it can shift to the secondary route. So let me ping again. Yes. Okay. Let me trace route. I will not ping trace route. Now we are using the secondary route for 20.20.20 because I've made this route to be unavailable. So automatically packets have been moving through different or through the secondary route. So that's how we configure the floating static route. We have to configure the backup in case one fails. We just move on to another or shift to another. So that's what floating route does. Now let's move on to another concept, to a default starting route. A default route is a static route that matches all packets. A single default route represents any network that is not in the routing table. Routers commonly use default routes that are either configured locally or learned from another router. The default route is used as a gateway of the last resort or result. Now, the default route is a static route that matches all the packets. The default static routes are commonly used when connecting an edge router to a service provider network, or a stub router, a router with only one upstream neighbor router. IP version 4 default static route command syntax for IP version 4 default static route is similar to any other IP version 4 static routes, except that the network address is normally 0/0.0.0 and the subnet mask is the same 0.0.0. So the default route we configure for this router to access. Maybe we have another router here with different networks, different networks, more than one networks. Instead, router 1, router 2, instead of configuring destination to each network, we configure a route which will cover every network here. That's why we are using 0.0.0.0. It means any network with any subnet is covered here. That's why we are using, that's the concept. Instead of configuring to destination to each router, to each network, we configure and cover all the routes. Our IP route, now our syntax is IP route, all network to all subnet mask next hop, IP or next hop exit interface. Let's just do the lab. I think we can understand it better with lab. But this is very useful for the configuration if you want to access the internet. Instead, because you don't know how many networks outside your local network, so we have to configure to occupy or to cover each and every route. So let's open our lab, default route. Okay, now we have this network. Let's start our devices. We have this network, and this is the service provider or the internet. We cannot specify the destination network because the internet, we have so many networks available. So we should cover every network. If we want to go to any network here, we have to pass through the net IP address. Let me run the console of router 1. Let's cancel this. The console of our PC. Still booting. Okay. Show IP interface brief. Yes, we have not configured the interfaces IP address, so we have to do that. Config T interface G1/0 IP address 172.16.2.1.255.255.255.0 no shut. Interface F0/0 IP address 172.16.3.1.255.255.255.0 no shut. Okay, we have to add the IP address in our PC. IP 172.16.3, so 3.100/24. Our gateway is 172.16.3.1. Okay, sure. Okay. Show IP int brief. Yes, 16.3.1, 16. Okay. Now Let us configure the root, static root. IP root, any network, any subnet. Our next hop is 172 service provider 172.16.2.2. Normally, in a real scenario, we don't configure anything in our service provider because everything has been sorted by the service provider. That's why here I've already configured the root on our service provider. Then there's no need for me to configure anything. I've just directed our routes to the service provider, and that's it. So IP route 0, any network, any subnet mask should pass through what? The next stop. Show IP route static. As you can see now, we have star here. It means these are default, and default we have said that is the gateway of the last resort. So any network, any host, and any network to any subnet mask pass through here. There's another way we can configure IP routes instead of netstop as IP address. We can configure netstop as the exit interface. Let me do it here now. Config T IP route 0/0.0.0.0.0. Our exit interface is G1/0. You can configure that, yes. Show IP route, show IP route static. Wow, you can configure, and as you can see here. So let us ping our Google, like here 8.8.8. Ping 8.8.8.8. You can see now we can ping. We can, sorry. Timeout ping. Let's try again. Yeah, we can ping we can ping. We can access our internet because of what? Of the static route. Of course, in real scenario, we should do more configuration in our router 1 to access the internet, to have access to source control and all that. But here, I want to just try to show you how to do it for the static route, and we'll use the dynamic, and we'll use the default static route. And thank you for watching. Please share, like, share, and subscribe. And please let me know if you have any question in our comment below. And also, please follow up. I'll be posting other videos later. Thank you for watching. You're welcome.